Curves defined by parametric equations. Imagine that a particle moves along the curve C shown in figure 1. It is impossible to describe C by an equation of the form y equals f of x because C fails the vertical line test. But the x and y coordinates of the particle are functions of time, and so we can write x equals f of t and y equals g of t. Such a pair of equations is often a convenient way of describing a curve and gives rise to the following definition. Suppose that x and y are both given as functions of the third variable, t, called a parameter. Curves defined by parametric equations. Imagine that a particle moves along the curve C shown in figure 1, currently being drawn. It is impossible to describe C by an equation of the form y equals f of x because C fails the vertical line test. But the x and y coordinates of the particle are functions of time, and so we can write x equals f of t and y equals g of t. Such a pair of equations is often a convenient way of describing a curve and gives rise to the following definition. Suppose that x and y are both given as functions of a third variable t, called a parameter, by the equations x equals f of t and y equals g of t. These are both defined as parametric equations. Each value of t determines a point xy which can plot the coordinate plane. As t varies, the point xy equals ft gt varies and traces out a curve C, which we call the parametric curve. The parameter t does not necessarily represent time, and in fact, we could use a letter other than t for the parameter. But in many applications of parametric curves, t does denote time, and therefore we can interpret xy equals ft gt as the position of a particle at time t. As a practice problem, sketch the curve by using the parametric equations to plot points. Indicate with an arrow the direction in which the curve is traced as t increases, given the following parameters. X equals t squared plus t. Y equals t squared minus t. Between -2 to 2 for t. And now, please take it away.
So, for the example, what you're going to start out with whenever you're doing this problem is you're going to draw a table. So, your table will contain all 3 variables. You'll have your t values, your x values, and your y values. So, once you draw your table with your t, x, and y, you're going to add in your boundary values and numbers in between them to get more points, to be more accurate. So you're going to start at -2, then go -1, 0, 1, and 2, which is the end point of the boundary. So to get your x values, you're going to plug in your t is -2 into the t's of the x equation. So -2 squared is 4 plus -2 is 2. So that'll represent your x coordinate when t equals -2. And then you're going to do the same thing with the rest of the numbers, going down the x column and then going down the y column.
Alright, step 1, you have your equations. Step 2, you make your table and you find your values. Now we're going to draw a graph. We're going to see what kind of picture it makes. This is the fun part, by the way. Had a fun time in GR. Alright. You got your x, you got your y. Now you have your 2 equations obviously representing each one. Your x and your y are your coordinates. So for example, when t equals -2, it's going to equal the coordinates 2, 6. So just like you learned in first grade. Sorry, 6th grade. 2, 6. So we'll say it's right about here. That's when t equals -2. Alright, after drawing all your points, now you should connect the dots. Starting from -2 to 2, because that's your parameter right here. You can't really see it that well, but this makes a parabola. It's slightly small, and I apologize, but it does make a parabola, and this is part of the whole thing for parametric equations. Thank you, my time is up.